Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 1-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to use linear equations to solve mixture problems. Now when I hear mixture here, I often think of chemistry, which yes, this calculation is done in chemistry pretty thoroughly. But you could do it in many other ways. One way that I've seen, for example, has to do with mixing coffee. Okay, because I used to work at a coffee house, and so we would look at how many beans we would need from Colombian roast versus another type of roast. Okay, so understand these mixture problems are seen in chemistry, but they're seen pretty liberally everywhere else in business as well. All right, here we go. So a lab technician needs 25% or 25 liters of a solution that is 15% acid for an experiment. Now her problem is that she only has a solution that's 10% acid and a solution that's 30% acid. Alright, so this lab technician is going to have to kind of mix and match their acid solutions to try to get a 15% solution with 25 liters. Okay, so how many liters of the 10% and the 30% solutions should she mix to get what she needs? Ooh, I should have waited to color code this. Let me go ahead and fix those real quick. I swapped my red and blue accidentally. My green was on the ball though. So take a look at what they say. So 25 liters of 15% acid. Okay, so of means multiplication. So they're taking 25 and multiplying it times 15%. Now, that 25 liters of solution is going to be made up of 10% solution and 30% solution. Now, I don't know how much 10% solution I need, so I'm going to call that X liters. Okay, some certain amount. So, to know the number of liters of the 30% solution I would need, I would take that X and subtract it from 25. And that should be the remaining amount. So, for example, if X was like 5, for example, I would need 20 liters of the 30% solution. Do you guys see that kind of difference there? Alrighty, so here is where they're starting to write it out in mathematical equation terms. So this was more English, now we're looking at math. So notice the first thing, they're converting our percentages to decimals. So I'm going to go ahead and put a big old note here. Make sure to convert from percentages to decimals. If not, you're going to be all messed up. Now, like right here, they flipped it. They kind of changed the order. Remember, this is multiplication, so it doesn't really matter whether the 15 is first or second. Okay? They did that because traditionally in mathematics, we usually have the variable after the coefficient. So here's our 10% solution with X liters, and here's our 30% solution with 25 minus X. So our next step that they're doing in this is they are actually multiplying them together. So 0.15 times 25 is 3.75. Here they just dropped a 0. I don't really know why, but okay. And then here they used the distributive property in order to get rid of these parentheses. Now, are we done with this question? No, but let's continue. So now that I'm at this point, what I need to do is I need to collect my like terms. because I have an expression here with x and an expression here with x, and we don't like having multiple x's just floating around. All right, so the left-hand side of the equation stays as 3.75, but on the right-hand side of the equation, I'm keeping my 7.5 and combining the 0.1x and the negative 0.3x to say negative 0.2x. Now remember from our previous examples, we are trying to isolate the variables. We're trying to get x alone. So my next step to get rid of this, like to get the x alone, is to get rid of the 7.5. So I'm going to go to each side of my equation. Sorry, I'm running out of colors here. And I'm subtracting 7.5 from each side. Now you might say right here, but Miss C, there's subtraction here, so you should do addition. Do you see how the 7.5 is positive? This is like plus 7.5 minus 0.2x. And so that's why I'm subtracting, is because the 7.5 is the positive value. Now I don't actually know that subtraction in my head, so I'm just using my calculator. So 3.75 minus 7.5 is negative 3.75. And that's equaling negative 0.2x, because you see that minus 0.2x here. Now my next step is to go ahead and get the x alone. So that x is being multiplied by negative 0.2. And so to isolate my variable, I'm dividing by negative 0.2. Okay, so when I do that, I get 18.75 for my value for x. So remember that x here is describing the liters of 10% solution. So I would say she needs 18.75 liters, is a capital L, of 10% solution. And then I need to go ahead and figure out the amount of solution for the 30% solution. So to do that, I'm just coming back right to this part right here. So I'm going to do 25 minus the 18.75 that we just got. And that'll tell me the amount of the 30% solution. So when I do that in my calculator, I get 6.25. So I'd say and 6.25 liters of the 30% solution. All right, so let's go ahead and let's try this again. So now our lab technician needs 30 liters of a 25% acid solution. How many liters of the 10% and the 30% should she mix to get what she needs? So now notice this percentage for the acid that I need, or that I want, I should say, that's higher, so it's closer to 30%. So I most likely need more of the 30% acid than the 10% acid. So that's a thing to be aware of to help you to kind of realize that you might, to help you check yourself. All right, so first I'm going to set the green equal to the blue plus the red. So 30 liters times 25% acid is 0.025. All right, so there's my number of liters times the percentage of acid. And again, I'm adding the red and the blue together. So my 10%, I'm going to say is 10% times X number of liters plus 30% times, now I don't know how many liters this X is, I know I need 30 liters total, so if I subtract whatever that X value is, that'll tell me how much I need for the red amount. Okay? And so now we need to kind of start cleaning things up. So looking at this, I can right away see that I could do 30 times 0.25, which if I do that is 7.5. And I can't do anything with this 0.1x until these parentheses are gone. So I'm going to go ahead and distribute to my parentheses here. So 30 times 0.3 is 9. And then 0.3 times x is 0.3x being subtracted. Now I have this x and this x, so I need to collect my like terms, which is what I'm doing next. So 7.5 is equal to 9. And when I collect those x's, 0.1 minus 0.3 is 0.2 of an x. So now looking at this, right, we're trying to get x alone. So I need to move this 9 to the other side of the equal sign. That 0.2 is being subtracted from 9, but 9 itself is positive. So that means that I need to subtract 9 from each side of the equal sign. So when I do that, here I get negative 1.5 is equal to negative 0.2x. I'm actually going to double check that with my calculator because some days, y'all, that's right. And this negative 0.2 is being multiplied to x. So to undo that multiplication, I'm going to divide both sides of the equal sign by negative 0.2. That didn't quite feel right. So I'm just double checking on my calculator. I guess so, y'all. So 1.5 divided by 0.2 is 7.5 is equal to x. So out of my 30 liters of solution, 7.5 of those liters are the 10% solution. Okay, so she needs 7.5 liters of the 10% solution. So then we need to figure out the 30% solution, right? So if I'm making a total of 30 liters of material, and I know that 7.5 liters of those are the 10%, then the remaining number of liters should be my 30%. Or sorry, my 30 liters. So when I do that, I get 22.5 liters of the 30% solution. And then remember at the beginning, right, I was saying, well, 25% is closer to 30% than 10%. So that's how I knew that I needed that more of that 30% solution. So see, I have almost 3 times the 30% solution than the 10% solution. So there we have it, guys. That is how to use linear equations to solve mixture problems. Until next time.